This lesson is on factors and greatest common factors. This lesson is going to refocus our attention back on prime factorization, which you might have seen in 6th grade or even in elementary school. So it says prime factorization is a representation of a number or a polynomial as a product of primes. Remember, a prime number has exactly two factors, itself and 1. And the number 1 is not prime because it only has one factor. So remember, we are working with prime numbers using prime factorization. We're also going to be looking at what's called the greatest common factor in this section. Factors that are shared by 2 or more whole numbers are called common factors. But the greatest common factor, the greatest of these common factors, would be called the greatest common factor. So let's look at some examples here of writing the prime factorizations and also finding the greatest common factors as well. For A here we have 40. So we need to think of what two factors create 40. Well, 2 and 20 is an example. Remember, there's more than one way to find products that create that value 40. And when you find the prime factorization, when you break this down, you end up with the same answer whether you use 20 and 2, whether you use 4 and 10. But notice we use 2 and 20 here. We cannot break down 2 any further, so we circle 2 here. We can break down 20. We could use 5 and 4. Here we use 2 and 10. So we circle 2 because we can't break that down further, but we can break 10 down into 2 and 5. So notice how many 2's we've circled, 1, 2, 3, and we have 1, 5. So the prime factorization is 2 times 2 times 2 times 5, or another way of saying this is 2 to the third power, because we multiply 2 by itself 3 times. So 2 to the third times 5. Let's look at B here with 33. What are two factors that, or what are two products, I should say, that give you 33? That would be 11 and 3. We cannot break 11 down because that is a prime number, so we can circle it. We also cannot break down 3 because that's a prime number. So 3 times 11 is 33. So my final answer would be the prime factorization of 33 is 3 times 11. Look at here at 49. What two values, what two products make 49? That would be 7 and 7. 7 and 7 are both prime numbers because they can only be multiplied by itself and 1. So we circle 7. And the prime factorization of 49 is 7 times 7, or 7 squared. So I hope this is a good review because, like I said, most of you should have seen this previously. Now we're looking at the greatest common factor, or sometimes you'll see it as GCF, of each pair of these numbers. So for A, we have 12 and 16. So there's two different methods. The first set here, 12 and 16, what we can do is list our factors. So we'll list all the factors of 12. That would be 1, 2, 3, 4, 6, and 12, because 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. But now let's list all the factors of 16. That would be 1, 2, 4, 8, and 16. So now what we have to do is we have to look at what values, what numbers, are both in factors of 12 and 16. So notice the red values, 1, 2, and 4, are in each of these. So the greatest common factor of 12 and 16 is going to be 4, because that is the greatest value for 12 and 16. That would be the greatest common factor for both 12 and 16. Now for set B here, we have 15 and 25, and we're going to be using prime factorization. This would be the second method you could use with finding the greatest common factor. So what we're going to do here is we can find the greatest common, or work with prime factorization of 15. 15, you get 1, 3, and 5. For 25, we have 1, 5, and 5. And so what would be the greatest common factor of both 15 and 25? What value do you see occurs that would be a product of 15 and 25? That would be 5. So the greatest common factor of 15 and 25 is going to be 5. Let's look now at this other set. It says find the greatest common factor for each pair of monomials. Notice we only have monomials, mean there's one term. For A, we have 18g squared and 27g to the third. So what I'm going to do is find the prime factorization of 18 and 27. So prime factorization of 18 would be 2 times 3 times 3. And then we have g squared, so that'd be g times g. The prime factorization of 27, g to the third, would be 3 times 3 times 3. And then g times g times g. So looking at both of these, which value occurs would be the greatest common factor? We'll notice 3 occurs twice for both 18 and 27. And g's occur twice for both 18 and 27. G to the second, g to the third. So we brought down 3 times 3, g times g. So the final answer, the greatest common factor of 18g squared and 27g to the third is going to be 9g squared. 3 times 3 is 9. G times g would give me g squared. For B, we have 8x and 7v squared. So I can write the prime factorization of 8, which is 2 times 2 times 2. And then for x, we just write x there. For 7v squared, that's going to be 7 times v times v. Notice there's no number or variable in common with each of these. So the answer to this, the greatest common factor, is actually just going to be 1. So if you can't find anything in common, remember with prime factorization, 1 will always be a common number. So the answer to this second part here is 1. That is it for these notes, and I will see you in class tomorrow.